Okay, hello, can you hear me? Hello. Okay, thank you. Okay, so let's continue. Okay, so now we talk about that how we can easily export any shapefile from Google Earth Engine. So actually Google Earth Engine have lot of shapefile is already available. Different types of cities or different types of province we can easily get it. We already discussed about that one dataset. Suppose I simply search here if a just a minute load it if a o and imported that this dataset which is okay. Yeah, so first level, second level. Just I import the second level. This data set, we already know about the data set and how to use the data set, we already know about that. Okay, so I think first class we try to discuss about that, how it will work. So this data set, I just simply take a variable, suppose RY, and then I take the table. This table I filter. How I can filter Earth Engine dot filter dot equal, and then I set the name, basically filtering process. So we can easily get it from the table schema. So here you can see about the filtering process. So just I choose here the name of the administrative unit, second level. Just simply copy and then paste here, and I put my specific city's name, suppose Dhaka. So now further we try to add the layer. We already discussed about this code. Okay, so just I will show you that how we can easily export the shapefile, suppose Dhaka city shapefile or any other cities which are available in Google Earth Engine. So map.center object is RY, view level 10 and click to run. So now we can easily visualize our Dhaka city's Dhaka district boundary. Can get it. So now I export this shapefile. Okay, so first of all I try to print and check the data type. So print the RY. So it shows about the feature collection. Okay, it shows about the feature collection. So in this feature collection, here you can see all of property. I can get the feature, one feature column. So in this time we can get it. So now let's try to export it. For exporting the shapefile, we take a just use the code export table to drive. Okay, for image we are just using export image to drive, but it's a shapefile. So shapefile we just use the export table to drive and further put all of argument one by one. So just I make a curly bracket start and also curly bracket end. Okay, and then further collection. So mainly collection is that our feature collection which is ROI. Okay, then description, anything I put here, the suppose Dhaka. Folder, you can put any folder name. Suppose I put the folder, any name you can put. So BNB, or you can put any name as a folder name. File is not net. File format is net. And this time I need for that SSP shapefile. Selectors, it's not net. Okay, right. So now try to run the code. So now our task tab will be running. Click on the task and then run and click run. So now we let's check what happened. So now it's working. But it shows a problem. What is the problem? Shapefile cannot contain the multiple geometry. Okay. Okay, so let me try with another data set. Suppose US to US data set, I want to for the country level boundary, what happened? Yes, just I change the table to, and then filter the country in a, and I put the country name, suppose Bangladesh. Run the code. So now I can get that Bangladesh country boundary shapefile, and this shapefile I want to export. So it's working. So in the meantime, I try to discuss about another topic. Okay, not only for this shapefile, you can also export the shapefile. You can see it will be done. Okay, so I think some problem on this data set, for the first data set have some problem, so that's why it not work. Okay, but when I use the US data set, then we can easily get the shapefile. So further from here, you can easily download that all of file from here, open in Drive. Okay, so now we try to another way. Suppose I just digitize a specific boundary, and then I just try to export the shapefile. Suppose I just open this satellite view, and using this way you can easily export any kind of lake shapefile or river shapefile or any specific boundary georeference shapefile you can easily generate from here. So it's very easy. Suppose this lake, I want to export this lake's boundary shapefile. So just click on here. This is the draw shape, click on here, and then just digitize your study area. Okay, just digitize one by one. We can just digitize our study area, and from here we can easily get this shapefile. Okay, I take the roughly. Okay, so using this process, any river boundary or any shoreline, you can easily get it. The boundary shapefile you can easily generate, and further work with this other geospatial software. And finally double click in here. Yeah, so this is my polygon. I want to export this shapefile, okay, from here. So here you can see it imported as a geometry. Okay, this geometry I put it suppose as a AOI or area of interest, or you can put any name. So this I simply print, suppose just print this AOI, click the run. So now it show about this result under the console tab. You can see it show about that type is the geometry. Okay, so geometry computing. So this AOI is a geometry. So this AOI I want to convert into feature collection. So here you can see first one is the feature collection. It also show about the feature collection. So first of all I need to convert feature collection. So just take a variable. So I put the variable name, suppose COL, or you can put any name. So just user e dot feature collection. Okay, and put this AOI. Okay, so now if I print that, suppose I print this COL and click the run, it computed as a feature collection. You can see here we can get the result feature collection. Okay, so run the code again. So first of all we convert a geometry, we convert into feature collection, then we apply this export Okay, suppose in 1 year, suppose January to December year of 2014, all of images, create the middle pixel will and create the median composite. Okay, and further we are returning the set year, and then we can print how much image we can get. We are just print the annual. This is the variable name. Variable can be anything, it's not, doesn't matter. So just type annual, this is my variable name, annual NDVI. So just I put here annual NDVI, then we can get the 10 images. Okay, here you can see we can find out the 10 images, and all of images we can get the 20 bands, and we already added the band. So here you can see we already added this type of band, NDVI, NDWI, and EVI. So I already added this type of band. Okay, I already added. So that's why it shows about this type of band. And further we are just make the time series chart using the UI chart image.series, and I mentioned about the band name, and then we can easily get this annual time series chart. Look like that. This is the annual time series chart. Here you can see January 24, then 2015, then we can get the 16, then we can get that 17, and up to 2023 for all parameter EVI, NDVI, and also other parameter NDWI. We can get it. So this is the annual time series chart, and further we talk about the monthly time series chart. Same process for the monthly. For each month, suppose year of 2014, 12 month, January, February, December. So for doing these things, we are just use the same code. At the same time, we are just take the year. We create the two function. You can see here. It's a one function. This is the another function. So one function for year, another function for the month. So I call the Landsat 8 again and filter the yearly. First of all, yearly, and secondly, we also filter monthly. Okay, monthly median composite. Suppose month of January, all of images create this median composite. February, all of images create this median composite. Okay, and further we take it. You can see here how much month we can get it. We can get the 120 month. Okay, for 2014 to 2023, we find out total 120 month. Okay, and further we make the time series chart. Same process. We are just call that monthly. Okay, and then we just simply get this data. This type of data we can easily get it for the monthly. For each month, suppose 2015, all of month. You can also download the data from here also. So basically, this is the process to work with annual and monthly time series chart. So you also try and further apply this code for other study area. Then I hope you can easily get the more better idea. Okay, so I will send you all of practice code. In the meantime, we talk about that problem solving class for the previous class, or any confusion for any doubt you can also share with me, then I will also try to explain. Okay, just simply share the screen. If you have any problem, then I will guide you. Okay, so any question or any problem?
Yes, sir. Hello.
Okay, so if you have any books, only you can simply share the screen and then show me your problem. I will try to fix it.
Hello.
Yeah, please.
Sir, you told about the wet season or dry season. I tried for the to cover the whole India, but it doesn't show the dry season or wet season separately.
Okay, so can you see share your screen? It was more
Yes, sir.
better.
Yes.
Yeah, please. Please. Okay, we can see your screen. Yeah. Okay. Okay, for the wet season, it's not loaded, or for the dry season, it's loaded. Yeah.
Sir, it is loaded, but not showing the exact result.
Okay,
Right now it is time.
okay, so it wait for that. I think it also happened for that networking issue or other. Mhm. Because it's very big study area, so that's why.
Maximum time.
Okay.
Sir, this is it is like this. When I'm
It's dry season.
yes, sir, it's dry season, and when I'm putting the wet season, then this portion which shows the white, it also shows the black. That's it.
Okay, so
Actually, I
okay.
tried this code after seeing your YouTube video. So I
Yeah,
already have this type of code. So right now I just put the boundary, India boundary, and showing like this.
Okay. Okay, so image dry season is loaded and wet season is not loaded. Okay. Okay, can you check it how many images are available in the wet season?
Wet season.
Yeah, so simply go to the below and then check it how many images are available in the dry season. Okay, so just simply commenting the mosaic and clip and then try to use the size function and then check how many images are available in the wait season. Yeah. Just run the code. So not computing how many images collection, how many images are available in this collection. It's crazy. Or if you want, you can also simply click on the get link button and send me the code link in Google Meet chat box. Then I also try to open it from here from my side. Okay, so let me open.
So one.
Yeah, please.
I have a problem also.
Yeah,
Can you able to see my screen?
yeah, I can see.
Yes, sir. When I'm using this code, like India boundary, continue this type. After using the median function, this portion is not covered.
Okay, so this problem is that you can check your cloud cover level first.
Okay, so
How much cloud you want to use in
first
here?
of all, when I'm showing the ROI region, then it should be covered.
Yeah, you check your cloud cover level. Okay, so simply go to the below of the code and check the cloud cover. Yeah, so you can use that the less than 1%. It means that some place we don't get the image. It means that for this place less than 1% cloudy image is not available, so that's why it not fill up. Okay, just you can simply try to increase less than 5% and then check. I hope it also work, or if not then try to increase the 10%. Okay, then it also fill up.
Okay, sir.
So it means that for this study area is not available less than 1%, so that's why it show as a blank image.
Okay, sir. Yes, sir.
Yeah, so now it's fill up. Yeah.
Thank you, sir. Sir, last time you shared a link for downloading the shape files. But I'm still not get this.
Okay, so I will send you a video about that, how we can easily get the country boundary or administrative area using the natural art data. I also make a video. So currently GIS DIVA GIS is not working, so that's why we try to find out another solution. Okay, I will send you the tutorial about that. You try to use.
At the sir, in first assignment, I'm unable to find the area of circle area. I think first question was.
Yeah.
I didn't get any hint how to start. I tried
Okay.
to start.
Okay, for the circle area, mainly in this time, any users give a circle radius. Okay, so it's not use this type of things is not need in this time. At the just it's a calculation. Okay, suppose any users give the circle area 5 meter, so your code automatically calculated pi r square, pi into r square. These things automatically calculated. Same as like our when you make the function for calculating two numbers, just we input the number, it automatically computed subtraction, addition, division, multiplication, automatically calculated. So this same things, suppose any users give a number, mainly radius, it automatically calculated pi r square.
Okay, sir.
Okay, so you try and we can get it, no problem.
Thank you, sir.
Okay, so how it is again validation. Okay, so in the visualization, we set some color. So basically, you can see our code. In this code, we can put here. Okay, so let me open this code. Where is it? Suppose we put here the blue, green, blue, white, and green. So blue is indicating about that your all of negative pixel. So here you can see we already defined that mean and max value. Okay, so all of minimum, negative, it's indicating we show the pixel as a blue color. So greater than negative pixel, it can be 0 or 0.1 or 0.2. We consider it as a white color, but this white, it's a positive, but it's not a vegetation. So greater than white color all of pixel, we consider as a green. Okay, green, it show the maximum NDVI value. Okay, so maximum means that it can be 0.5, 0.4 or 0.3. So just it make the gradient. Suppose in the gradient, suppose in the ArcMap software we create some gradient. So in the gradient we just put the suppose negative, this is our low value, and positive is the our high value. So then it gradually increased. Suppose -1, then gradually increase. Okay, and it also show about the color bar. So you can also get the more idea about that when I add the in here in a legend, then you can easily get the more better idea. So now any question about that, then I will show you that how we can easily add the legend, gradient legend. Oh sorry, just let me share. Okay, now can you see my screen?
Yes, sir.
Okay, thank you. Okay, so in this code, okay, so in this code here we can put here the -1 to +1. Okay, so it gradually increase. Suppose blue is the low pixel of NDVI, then greater than all of white is greater than all of blue pixel, and green is greater than all of white pixel. Okay, and for NDVI is high positive value, always indicating the vegetation. Okay, and negative pixel all time indicating the water body. So that's why just as similarity we are just show the water body as a blue color and vegetation high NDVI value show as a green color. So that's why we can easily identify this is the vegetation green color and this type of things is the blue color is water body. Okay, but it also some white color pixel. So this white color pixel, it can be your very low NDVI value. Okay, if you want to check the value, suppose click on here, then check about this value, we can get the very low NDVI value. You can see here we can get that 0.01, okay, 0.1. So it can be very less vegetation or barren land or snow or rock. So it also more better, you can easily get it from the more information for NDVI already. I think this website, okay, let me check it's available or not. NDVI range, I simply search here NDVI range. So now we can get the all of pixel indicating the different feature. Suppose click on here. Here you can see this is they already get this type of things. So you can see areas of barren rock, sand or snow, it show very low NDVI values. For example 0.1 or less, it show about that all of barren rock, sand or snow. But negative pixel always will be water. Okay, when you apply the NDVI negative pixel, it's indicating about that water body. Okay, then also you can say about the sparse vegetation such as shrub, grassland, it can 0.2 to 0.5. Okay, and dense vegetation, it should be 0.6 to 0.9. Okay, so this is the range about that. So using this range, gradually we are just use this type of color. Suppose in this time we are just use at that for negative pixel we are show as a blue color, greater than all of negative pixel we are just use the white color. White is not negative but it very low pixel value. It can be barren land or it can be rock, it can be snow, but not vegetation. And then further we are just put the green, it's indicating about that all of vegetation. So in this vegetation it can be dense, you can see some is very the deep green color, so you can see it's a deep green color, so it's a dense vegetation. You can check the value from here, it show about that the value 0.2. Okay, 0.2 we can get it from here. Also you can see you can get the some sparse or green vegetation, sparse green, but it also vegetation but it's not much green. Okay, just I open it. Yeah, so here you can see you can get this type of things. Suppose in this map it's an NDVI map. Okay, previous one is the SAVI map. Okay, so that's right. So it's the NDVI map. In the NDVI map, you can see we can get this type of result. Okay, so you can see we can get some place is the more green. Okay, so it's the indicating about the dense vegetation. So you can see you can get that 0.6. Okay, it's the dense vegetation. Some place is not much deep green, but it also some low vegetation. We can get, suppose click on here and check about this pixel. What we can see about the pixel is that 0.5. Okay, so it's the sparse vegetation, not mass, because according to this link, so here you can see they are provide the range. Dense vegetation approximately 0.6 to 0.9. Okay, and sparse vegetation 0.2 to 0.5. Okay, so we are using the different types of color based on this trends, and then we can easily get it. Okay, and always NDVI negative pixel will indicating about the water body. Okay, and then we can find out that very low pixel 0.1 or less 0.1. We find out that different types of barren rock, sand or snow. Then we find out that suppose your 0.2 to 0.5, it's a moderate. We find out that sparse vegetation, and high or dense vegetation 0.6 to 0.9. Okay, so we set this type of color from here, and we can easily get this map. And further we try to export. Suppose you can see all of map, which I already show you that. So this type of layer, all of layer we can easily export, and further we can easily make the map using QGIS or ArcMap. So these things further I also try to explain.